Jai Jendra, Namaste and welcome to my channel. Today we are going to solve the 51st question of the problem solving series and the third question of Q data structure. This question's difficulty level is easy to medium and this has been asked in Google, Amazon and Yahoo. Okay, number of recent calls. So we have to implement a recent counter class which has a int ping function which gives the value of the number of recent calls that has happened between t minus 3000 millisecond to t millisecond time frame. Okay, so let's look at the example and then probably the question would be clear. So we have these two arrays, okay, of string, and we have this recent counter. When it's given as recent counter, then the class of recent counter is formed, right? So so once the recent counter class is formed, so this would be obviously empty string. Then this ping is the call to the recent counter at t time. Okay, so this is in the unit of millisecond. Okay, so the first call that has gone to the recent counter has been gone in 1 millisecond. Okay, so in 1 millisecond this is the first call. Next call goes in 100 millisecond. So you need to understand that between 0, so if you see, if this is a recent call, recent counter list, okay, this structure in recent counter, maybe anything, array, list, anything. So the first call goes to the recent counter with the ping function in 1 millisecond. The next call goes in 100 millisecond. Okay, so after that the call goes in, another call goes in 3001 millisecond, and after that the other call goes in 3002 millisecond. Okay, now this ping function will return the number of calls that has gone between this time frame. Okay, t minus 3000 to t. Okay, let's solve this example and then we will see how we'll implement this reset counter class, the ping function. Okay, so when we call it for the first time, so in this case 1. Okay, so here when the call function is called, we return null. Okay, next when this 1 is called, that means we need to find out how many calls are there in the recent counter between this frame. So we need to calculate this. So 1 is the value of t. So 1 minus 3000 is minus 2999. Okay, and then t. Okay, so between this time, how many times the recent counter has been called? This is what we need to find. We know that the time frame cannot be negative. Okay, so we have to find in 1 millisecond. This value is anyway not there. This is the least, so it will start always with the first value, right? So minus 2900, there is no point of having going back, obviously. So in 1 millisecond, this is called one time, right? So it would be, the ping function would be returning 1. Now in the 100 millisecond, there is another call to the recent counter. So we need to check how many times this ping function will check how many times this recent counter has been called between this time frame. So what is the time frame? Second time frame. This is the first time frame, this is the second time frame. So 100 minus 3000, that is minus 2900 and 100. Okay, so between this time frame, minus 2900 to 100. So first limit is minus 2900 from the beginning, that means, and 100 is the second limit. This is the second limit. So till 100th millisecond there have been 2 calls. One in 1 millisecond, the second in 100 millisecond. So we'll return 2, right? In the third case, 3001 millisecond, after 3001 millisecond, there is another call. So now what would be the limit? So the left limit would be 3001 minus 3000, that is 1. 3001 minus 3000 is 1, and this will obviously be this value, 3001. So between 1 to 3001, in 3001 there has been one more call, and between 1 to 3001, that means we start from here, 1, this and this, 3 times this recent counter has been called. So we'll have this 3. Now this fourth call, 3002, in the 3002 millisecond, there is another call to recent counter, and we need to calculate this limit. 3002 minus 3000 is 2 and 3002, right? So between this time 2 to 3002, so this 1 will not come because this has been called in the first millisecond. We are checking from second millisecond. So from second millisecond these values would come, right? So 1, 2 and 3, not 4. Okay, this will not be called. This will not be counted. Okay, so we return 1, 2, 3, 3. So now how do we solve this? So one thing to observe is that this time intervals, this will always be in increasing order, right? It can't be like 150, right? Because it's increasing. If it's called 100 milliseconds, then it will be called after 100 milliseconds. That's obvious. So we need to take this observation, right? Now how do we solve this? We are talking about Q, but you need to find the intuition. Which data structure should we use? Why should we use Q? Why should we not use stack or vector? That means array. So now the thing is, we need to find so we always know T is the limit, right? So whatever value we get here, that is going to be the right limit. We are always concerned with T minus 3000 value, right? So this value will always be in an increasing order, right? So if we calculate this 330 minus 3000 every time, and then we check, okay, if this T minus 3000 value, is it greater than 1? If it is it greater than the first value that has gone inside it? It could be 5, 4, anything. If it is less than that value, like for example minus 2910, we don't care. We will just return the number of elements that are present in the structure. Either it is we take stack, queue or anything, right? So we'll return it. We have solved it. But the other part is, if for example this one, we see that the T minus 3000, this 2 value, right? 3002 minus 3002, this 2 is actually greater than its first value, right? So we need to exclude this. We should not have this value in the first structure. Suppose if this value was 500, right? Then we see the first value that is not required. We see the second value that is also less than 500. So we don't need this. We need these values, right? So tell me one thing. If this value is 500, say after this there was another 3500, right? 3500, right? Then what would have been the limit? It would have been 500, comma 3500, right? If this was the another value, then we would have excluded this one, and we would have given this 2 and this 3 value, right? If there was one more value. So what do you think? We are always checking with the first value. What is the first? If it is not required, like in this one, we know this is not, one was equal to this, but here 2 was there. So after that, any 3002 was there, anything would come that would be greater than 3002, right? So we don't need to check for this previous value only, right? Because that won't be included because the time frame is increasing. So what do? We are checking the first value. If it is required, then we are returning, if it is less than that, then we are returning the size of the structure. If it is not, then we need to remove it so that next time we don't check this value, because this value will always be lesser than this value, or the difference, T minus 3000, right? Once it has crossed it. I think you're getting my point. So what data structure suits this problem statement? Q, right? First in, first out. If that value we don't need, for example here 500, we don't need this one value. We should have eliminated this one from here. Then 100 is there, then 500 is the difference. We should have eliminated this and we should have returned the next one. And then we should have checked this value, because the next value will always be greater than 3500, right? So this way you need to think, and this is the intuition. So let's code it. It's very simple. What we'll do, we'll take a Q, and then we will see if this, whatever the value is there in the ping T, if T minus 3000 is less than the Q dot front first value, that means what? We return the size of the Q, right? But if it is greater, then till the time it is not smaller, we will pop out the values from the Q. Once it is smaller, popped out the value 100, we will return the length of the queue, right? It's very simple. So recent counter is simple. We don't need to, this is a constructor, we don't need to do anything here. We can take a queue data structure here, okay? Queue int queue, right? And what do? We check, okay, while, okay, we take the value as int left limit, okay, left limit equal to t minus 3000, whatever the value is there, right? So if q dot front is greater than or equal, if it is not, right? So we just need to, if it is greater than, if the first element is greater than the t minus 3000 value, we return the size of the queue, right? So we will not talk about this condition because every time we will return the size of the queue after eliminating the values from the queue. So we'll talk about the other condition and we'll just use the while loop, right? So while q dot front is actually less than left limit, then what do? We pop out from the queue, right? If it is equal or greater, q dot front is greater than this left limit, then what do? We return the size of the queue, q dot size, as simple as that. Just you need to understand the problem and you need to use the right data structure. So in this way we can solve it in order of worst case order of n, right? And order of n is with the space complexity. I think the question is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough section of the 53rd question, number of recent calls. And we have taken the same example. And let's look at the code. One thing that I missed is in this ping function, we first need to push the time counter q dot push t, right? In this video you saw that we are making the list, so without pushing we can't pop it out, right? We won't have the q dot front, so every time we need to push the value, right? Because in the q dot push we will push the time frame in which we are calling the recent counter class. So this is one mistake from my side, so it's very obvious. We will first obviously push the q dot push the time frame or the time second in which the recent counter was called. Other than that, everything was same. We are comparing this with q dot front, the first range, and if it is smaller, then we will pop out. We need to have the value in the queue, the front value, always greater than the first range, right? Or equal to the first range, so that we can include it into the number of recent call counter, right? So let's directly submit this code. You can see this has been accepted. So let me know about the explanation and the questions type. You can see this has been recently asked in Google, Amazon, Bloomberg in 6 months to 1 year. Though it's very easy, but we need to solve it in order of n time in the worst case, right? And when the counter is greater, it returns. When the q dot front is always great, if it is greater than the first range, it returns in order of 1, right? So that is the important thing here. Knowing the right data structure in the problem statement, using the right data structure to solve the problem, right? So yeah, see you all soon in the next video where I'll be explaining the 54th and the 4th question of the Q data structure. Thank you.